Section 8.6, we're going to be factoring trinomials again, except there's going to be one small difference, and it's going to be a little bit more work, but nothing we can't handle. And that difference is there's going to be what we call a leading coefficient in front, so we're factoring ax squared plus bx plus c. The a stands for something like this question where I'm setting up this rectangular solar array, and it's giving us the area, 3x squared plus 21x plus 36. They give us the height, which is x plus 3, and it's up to us to find the length. We know if we multiply height times length, that would make our area. And in our last couple sections, we'd say x plus 3 times x plus something is going to give me this 3x squared plus 21x plus 36. But just by having this 3x squared instead of just x squared by itself, it's going to be a little bit more steps in terms of solving it. But we can solve them. We can write trinomials of that form. Ax squared plus bx plus c is the product of two binomials like last time. So that was one binomial times another. And to do that, let's consider that we start with a trinomial, 6x squared plus 23x plus 7. Again, the difference in this section being I have a 6 in front of that x squared. So if I want to factor this, let's think of that middle term 23x as 2x plus 21x. We'll see why we get to that in a second. There's a way to factor this we call grouping. We're going to get into that more in section 8.8. But I could break that down as long as I have 2x plus 21x. Factor out the common factor of the first group, second group, and I eventually can write that as two binomials. Again, we'll get into that method a little bit more later. I have another method I use for this one that I think arranges that a little bit more visually. But why do I know that if I'm trying to end up with this factorization, why did I know to break that up in the first place as 2x plus 21x? So that was that middle term. Now I have four terms. The reason, because if I multiply 2 and 21, I get 42, which is the product of that first term 6 and that last term 7. So 6 times 7 is where I got 42, and 2 times 21 is also going to give us a 42. So that's what we're going to be looking for. We're going to be looking for factors of the product a times c. So that's very first number in front and our very last constant. Multiply those together. And we still want to have a sum of b, so just like the last section, we still want to add up and get that term in the middle. So what I've done is I've blacked out the question on the left, and I'm going to be trying the questions on the right to see if we can get the point across. And again, the first step that's different is our very first step actually, is where I take that first number and the last number when I'm setting up my x method. We're going to multiply those together and we're going to get 10. I think in the last section I put that number on the bottom, but it doesn't matter where do we put it. As long as we're multiplying numbers together, in this case we're multiplying again the 5 and the 2 to get the 10, that's going to be our first step here. Just like in our last section, though, we also want to add them and get negative 11 once we figure out the last two numbers that are going to be missing. So if I'm trying to think of factors that are work, just like our last section, I start with, I think, the harder example here. If they've got to add to get a negative and multiply to get a positive, we can only do that with two negative numbers. So if I did 1 times 10 to get 10, that's not going to work because 1 plus 10 is not a negative. But as long as I just do something like negative 1 and negative 10, I think that's going to work. Negative 1 and negative 10. If I multiply those two together, negative 1 times negative 10 is a positive 10. And if I add them, negative 1 plus negative 10, I get negative 11. So in the last section, we would have been done already. We would have just said that was just x minus 1, x minus 10, and we'd move on. Except if I try to check my answer here, x times x, if I was trying to FOIL this or box it, multiply it back out, just doing x times x is not going to give us 5x squared. So that's not going to be our only step. That's what I have this box drawn off to the side for. And we actually call this method xbox. We already did the x, and now to fill in our box, I do that with a negative 1 and a negative 10, noticing what I did to complete the x from before. Only thing we're going to add is we're going to add an x to that. Kind of like in our last example, we broke up that middle term. 23x we rewrote as 2x plus 21x. The only thing the x is for here is to figure out how to break up that number. So we broke it up into negative 1x and negative 10x. So still not done, although there is just one more step to do here, which is to find greatest common factors. And we're going to do that starting with the first column. If I take the greatest common factor of these two terms, 5x squared and negative 10x, I can factor out 5x from both of them. I want to do the same thing with that second column. Negative 1x and 2 don't really have any common factors other than 1, so we can factor that out. And also, whenever I see this negative 1x as my x term, I want to factor out a negative with it. So if this term is negative for my middle term, I want to make sure when I factor, I also factor out that negative. So if I do the same thing with that first row, again, just thinking of common factors, only thing I have in common here is going to be an x. Again, 5x squared is positive. And this is also a good way to check your work. 5x times x does give us that same result in the first box if I was to multiply it, so it looks like we're good so far. And if I was to do the second row, trying to factor out my greatest common factors, 2 goes into both of those, and since the 10 was negative, I want to factor that out as a negative 2. And now I already have my answer. So 5x minus 1, that was the top, x minus 2, that was the side. This is our factorization. Really just a couple extra steps to what we already knew. And what I would suggest is to try the one to the left of it. I'm going to reveal my answer now, not working through the steps. But if you guys want to pause it and try to see if you can follow along with the steps, should work the same as that one that we just did. But that's when our term was positive when I multiplied those together. So 5 times 2 is a positive 10. Let's see in this next example what happens when that's a negative instead. So in this case, I do 10 times negative 14. Again, that's going to be my first step every time here. I want to multiply first and last numbers together. In this case, I get negative 140. And we still need to use that middle term. We're going to add that and get a 31. And notice what I've also started with my box here. I noticed that these parts aren't going to change. Just like the box from last time, I start with a 5x squared as my first term and a 2 is my constant. I already know that 10x squared is the first term and negative 14 is my constant. What I'm trying to figure out here to fill out my x box is what's going to be the two numbers I'm going to split this into. And that's what our x is for, just like our last section. If I'm thinking of factors of negative 140, I could do 1 times 140, except remember that would just give us a positive. So if I need a negative number, I need one of my numbers to be negative here, and if my result should end up being a positive when I add them, it's going to be that smaller one that's negative. So if I add these together, it's obviously not going to get 31, even if I did negative 2 times 70, not going to work either. But I think if I use the factors, will work here. Negative 4 and 35 might be a little tougher to come up with the factors on that one, but that should be our correct factorization. Negative 4 times 35 multiplies to get negative 140, and it also adds together to give us 31. So what we're using to do here is, again, just fill out the box with those two numbers. Negative 4, we're going to tack on an x, 35, tack on an x, and now the last step is, again, just look for common factors. Doesn't really matter where you start, so you can even start with a first row. If I'm factoring out first row, I think I can factor 2x from both of those. Second row, same thing. If I'm factoring, I think 7 goes into both. Notice this time that, again, 2x I can factor from that first term and the second term. And 7, same thing. It factors into both of those, so it worked on both of those rows. So first column, trying to do the same thing. I think 5x would go into both as a common factor. And my common factor in my last column is going to be 2. And remember now it's negative because that x term was negative. We didn't do the 7 as a negative because 35 was positive. It always depends on that term we factored out. Negative 4, we factored out the negative along with it. So again, we already have our answer. Top of our box, 5x minus 2, our common factors, and 2x plus 7 across the side. And these other two questions are similar enough to ones we've already done. Again, I would suggest give them a shot first, but I'll reveal that answer now. So working through our same steps, we should get 3x minus 5 times x plus 3. And I have a word problem block, but I think you guys could do this one as well. Not really any different from the one we actually did, a little bit closer to problem 1, actually. They were all positive. Answer we get from this one, if I factor this just like normal, again, just working through our steps really quick, 8 times 15, I get 120. I need to add up to get 22. Numbers that end up working here are 10 and 12. Once I use that to fill in my box, I factor out my greatest common factors. And once I get the outsides of that box, that should be my solution. In this case, they're dimensions, so I didn't multiply them together. Just 4x plus 5 you could say is like a height, and 2x plus 3 you could say is like a length or like a base or something. So let's say if we start with a bigger polynomial. It looks kind of intimidating and tough like these last couple. So I start with something like 18x squared, negative 33, 12. It'd be kind of a pain to multiply together 18 and 12 because that should be our first step. But what I can do here is check for a GCF of the whole thing to begin because that could make it easier. If I'm looking for the greatest common factor, just like the start of this chapter that goes into all three terms, I think if I took the number 3, I could divide each of those terms by 3 and it would come out with an easier answer. So if I divide the first term by 3, I get 6x squared. Second term divide by 3, I get negative 11x. And last term divide by 3, I get a 4. It looks like it goes into all three. It was also our greatest common factor because 6 and negative 11 and 4 don't have any common factors left other than 1. So just like the start though, we got to remember that if I was to factor this, the GCF would still be outside. And that's actually how we're going to start our answer. We already know our answer is going to start with two binomials. And we also know that the GCF is going to be listed outside, just like it was at the very start of the chapter. And now we just work through the same steps we did on the last couple. I take the first and the last numbers, multiply those together to get 24. If I take that middle term, which was negative 11 as a coefficient, What I could actually do, again, what I should have done is start with my box, 6x squared and 4. That's not going to change because that was just our first and our last term, now that it's nice and simplified. And now it's up to us to figure out what two numbers will work. So obviously, if it's multiplying to get a positive, adding to get a negative, I could multiply two negatives together. Negative 1 and negative 24 is not going to work. Neither will negative 2 and negative 12. We could keep trying. I think negative 3 and negative 8 are the numbers we're looking for. Whoa, that's a weird 3. Let's try that again, negative 3 and negative 8. Again, what we're looking for is to multiply these two numbers and get our first and last, so 6 times 4 is 24, so is negative 3 times negative 8. And if I add them, I get my middle coefficient. That's what we use again to fill out our box. Negative 3, throw on an x. Negative 8, throw in an x. All we're doing is trying to figure out how to break up that middle term, negative 11. And our last step is just to look for our factors. So 6x squared and negative 8x. I can factor out, it looks like 2x. If I factor out the next ones, I don't think anything is going to come out other than 1. And again, since the 3 was negative, I need to factor that out as a negative 1. So moving along to the first row, I can take out 3x from both. Again, this is a good place to stop and check. 2x times 3x, looks like at least the first square is good, so we're on the right track. And for the last row, if I factor out, I should be able to factor out a 4. Again, pay attention to that negative 8x. I should be able to factor that out as a negative. All I got to do is list 2x minus 1, top of the box, 3x minus 4, that's our side, and this is our answer. One thing we don't want to forget is that 3 from the very beginning. If I factor out a greatest common factor to make this easy for myself, I want to make sure I include that when I list the answer. All we're doing is simplifying what's left. We still had that GCF to begin with. And again, if you're able to do that one next to it, go ahead and give it a shot. I'll reveal the answer now. Working through the same steps, I think the only difference here is our greatest common factor was 4. Once I divide that out, work through the x, figure out your two numbers, use those to fill in your box. And again, what you're doing for your box is just greatest common factor. What can come out of each row in each column, that's your factorization.